Oh, I found a boo-boo. Go back to number 2 and fix it. So this would actually be kx plus c. I forgot the k. Okay, so moving on, number 5. If I want to power back up, so I'm going to take the integral of x to the n. Remember, I'd have to power back up, and I will divide, by that new power. You'll see that magic work in a little bit. If I take the antiderivative of cosine, of course, remember how I got cosine. Oh yeah, it was from sine. So I'd have sine of x plus c. If I take the antiderivative of sine, well, remember how I got sine. Actually, I got a negative sign from cosine. So if I take the antiderivative of just positive sine, it would give me negative cosine. Again, think about taking the derivative of each of these that I'm writing in blue, and that you would in fact get this stuff over here. If I take the antiderivative of secant squared, of course that's going to be tangent, because derivative of tangent is secant squared. I bet you'll figure out the rest of these. If I do the secant tangent, oh, that's the secant version. If I do cosecant squared, that's negative cotangent. And if I do the combo, then that's negative cosecant. And there's my list. So let's try a couple. So on this first one, if I take the antiderivative of 4, that would have come from, that's the constant version. So this is like number 2. This is a number 2 example. So I would get 4x plus c. And think about that if I take the derivative, I do in fact get 4. So it works. And same thing here. I could pull the 3 out in front, and then I'm taking the antiderivative of x. And of course, I want to power that back up. So this is going to be rule, I'm actually using a couple rules. I'm using number 3, where I pulled that constant or that coefficient out. And at the same time, I'm using rule 5, because I'm about to power back up. So when I power back up, I divide by that new exponent, and then plus c. So there's my function, my new function, f of x. We'll call him capital F of x. So think of this one again as x to the negative 3. And so I want to power back up. When I go up, it'll be x to the negative 2. And then I'm going to divide by that new exponent, which is negative 2. And so I end up with, of course I'm not supposed to have negative exponents, so I'm going to bring it down. So it'll be negative 1 over 2x squared plus c. And then again, this is x to the 1/2. So if I want to power back up, I'll add 1 to that, so that'll be x to the 3/2. Oops, 3/2, not 3/3. Write what you say, Torres. And then I would divide by that new exponent. And of course, not wanting fractions in fractions, I can multiply top and bottom by 2. Boop. And so I get 2/3 x to the 3/2 plus c. So on this next one, of course, I can pull that 2 out in front. And then if I take the antiderivative of sine of x, I get negative cosine of x plus the c. So I could simplify that to negative 2 cosine x plus c. And then over here, keep in mind there's a constant there. It's a 1, even though I don't write it. And so if I take the antiderivative of that, I'll just get x plus c. That one's a little too simple for us, isn't it? And on this next one, I could split them because it's a sum. So this would be using rule number 4. And the antiderivative of x, well, I'm going to power that one up. And the antiderivative of 2 would be 2x, and then plus c.